Hello everyone. So we were watching loop related advanced loop related problems, guys. Okay. So now in this video we will see sum of series, guys. Okay. So this is this is it will seem to you that this is a normal thing, but it has really advanced use, guys, right? So this is why uh, this problem is important. Okay, so this is called harmonic series, guys. So we will see what's the use of it. Okay, so we will just discuss about it, and we will try to understand with a story. Okay, so this series is called the harmonic series, and the sum is referred to the nth harmonic number when evaluated up to n. Mathematically it is expressed as hn equals 1 plus half plus 1 by 3 plus dot dot 1 by n. Okay, so why do you need harmonic series, guys? So we may not understand everything now, but in future we will discuss about the use of it, right? So why do we need the harmonic series? The harmonic series appears in a variety of fields such as mathematics, computer science, physics, and even economics. It helps in analyzing and solving problems related to growth, efficiency, probabilities, and distributions. The series grows very slowly, but it tends to infinity as n, n tends to infinity, making it useful in understanding asymptotic behavior, guys. Okay, so let's see what asymptotic is. Okay, so asymptotic meaning. Okay, so you see, asymptotic is an adjective that means approaching given value or condition as a variable or expression approaches in a limit using infinity. Okay, so uh, real life story to relate this series. Okay, so we will just see a real life story. The candy sharing in a classroom. Okay, imagine a classroom with n students sitting in rows. Okay, the teacher decides to distribute candies in unique way. So each student will receive a fraction of candy based on their position in the row. Okay, so the first student will get one candy, the second student gets one half of candy, and third student gets one third of a candy, and so on. Okay, the teacher wants to know the total amount of candy needed to distribute candies fairly among all students. If you see, if the class is 5 students, the total candy needed will be these, right, this equation. So we will uh, this is the harmonic series of H5. The teacher uses the sum to plan the candy budget efficiently. Okay, so application to the harmonic series, guys. These are just advanced things, guys. This program to calculate the sum of this series is not hard, but the use of this is really advanced, right? Like computer science, the harmonic series appears in analysis of algorithms such as the average case time complexity of quicksort or binary search trees. Okay, it is used in coupon collector problem, used in economics, physics, game theory, in many more places, guys. Okay, many more I mean uh, cases we can use this. Okay, so now we will see the program, guys, how this program works and everything, right? So this is just as the normal program we saw before, that how we can uh, calculate sum of a series, or uh, sum of some, we know how to do sum, right? So only difference is uh, here we will get the fractional number, right? So this is why we are using double type of variable here. So for sum we will use double. Okay, so printf enter n. Okay, so we need to provide a number and then scanf percentage d, and this is for the taking input, right? So, and this is for loop, guys. So for loop starts from 1 and it goes up to n. Okay, so sum equal to sum plus 1 divided by I. So you see the program, every time we have one, one as a nominator, right? You see here, one as nominator every time, 1 1 1 1. So 1.0 is written here and divided by I. So I means I would be increased, guys, 1 2 3. This is how. Okay, So if we like, if you provide 10, the result is 2.93. Okay, so this it was easy to calculate, guys, but uh, maybe in future we will see the advanced use of it. Okay, so for now uh, we just understood how it works, guys. So we are going to the next program now, right? Now we will see a program uh, which will find us if a number is a perfect number or not. So we need to understand what perfect number is, guys. Okay, so if you take 6, okay, if you take 6, so how many divisors of 6 we have? 1, 2 and 3, right? Not the not 6 itself. Okay, so 1, 2 and 3, and if we add them, 1, 2 and 3, we get 6. So these kind of numbers are perfect number, guys. Okay, so if you can uh, you know try to think and find the next perfect number, guys. Okay, pause the video and try to do it, right? So if you see here, um, we are taking input from the user in these two lines, and we're having a for loop here, right? So what does this for loop do, guys? This for loop is trying to iterate and uh, trying to find it finds the sum of the divisors, right? And if sum is equal to the number, then we will say this is perfect number, and it's not, if you will say that it's not a perfect number. So what do we need to do? Maybe visualizing the for loop would be a good thing for us, right? Perfect number, right? So we'll just visualize this for loop, guys. So it may be the first iteration, so integer 1, and let's say uh, I starts from 1, right? So if you take 6 here, if you provide 6, so number is 6. 6 divided by 2 would be 3, guys, right? Number divided by 2 would be 3. And if number, so number is 6 modulus I means 1, right? So this should be 0. So sum would be sum plus I, right? So we can write in this way: sum plus I means guys, I means 1, right? So sum previous I mean in the beginning sum is 0, right? So 0 plus 1 means 1. Okay, so I will be increased now, and I will be 2, right? So when I is 2, it's for second iteration. I is 1, right? So here I would be you can say 2, and 6 divided by 2 equals 3. Okay, so 2 is less than 2 is less than 3, right? So 6 modulus 2 is 0. So in this case, previous sum was 1, and 1 plus I, that means 2, right? So it would be 3, guys. Okay, so why you need to why we are yeah, iterating why we're iterating to half of 6, right? Why? This is because there may be there cannot be a greater number than 3 which can divide 6, okay, except 6. Okay, so if you see, it's true for any number, guys. Okay, if you take a 32, then 16, there is no number above 16 or greater than 16 can divide 32 except 32, right? This is true for all the numbers. So for third iteration, integer I is 3, and 3 is not less than, but it's equal, right? So we can, and 3 is modulus 2 is right, and previous sum was 3, and 3 would be here, and 2 would be our I is 3 here, right? So is 3, so 3 plus 3 would be 6. So our for loop terminates here, guys, because it can't I can't be increased because this condition will be false, right? So now we'll if sum equals number. Okay, so in our case, if sum is equal to our number, right, so we can say it's a perfect number. Else we can say it's not a perfect number. So if we check, if we provide 6, then 6 is a perfect number. If you provide any other number like 12 or something, you say 12 is not a perfect number. I hope you understood, guys. Okay, now we will see an interesting program, guys. This is called Collat's conjecture. Collat's conjecture. So we need to we'll just discuss what it is, and then we will see the program, right? So Collat's conjecture is a famous unsolved problem in mathematics, okay, proposed by the Lothar Collatz in 1937. It is also known as 3x plus 1 problem, okay. So the conjecture involves a sequence of defined for positive integers. So uh, it starts with any positive integer, right? Maybe 8, 6, whatever it is. And if this number is evenly divided, okay, so then it's fine. And if you divide this number like 8 and like 6, and you will get 3, right? So you're getting an odd number. So if you get an odd number, then you need to do 3n plus 1, and then you need to put this value in this n again. Okay, so you have to repeat this process again and again. And this conjecture states that no matter what positive integer n you start with, the sequence will eventually reach the number 1, right? We will eventually will get the number 1, right? So you know uh, why is it famous? Let's just spend some time. Despite its simplicity, mathematicians have been unable to prove or disprove it. Okay, so it is an example of how simple mathematical rules can lead to complex and unpredictable behavior. Application. Although primarily a theoretical problem, studying the Collatz conjecture helps develop mathematical techniques in areas like number theory, dynamical systems, algorithm analysis. Okay, so okay, so we will understand these things later, but for now we're just focusing on our work, right? So you see here, I hope this function, this you will enjoy this program, guys. Okay. Okay, so we are taking input from the user, right? And now we are saying Collatz sequence. Okay, so while number not equal to 1, then we will print the number, right? If number modulus 2 equals 0, then we will number equals number divided by 2, else number equals 3 into number plus 1. So it's simple, guys. We can realize what it actually does. So if you want me to help you visualize this, let's conjecture. And let's say in our case we will take 6, guys. Okay, first iteration. So when it's 6 is not equal to 1 is true, and then when we will print the number, right? Print the number. If number modulus 2, so 6 modulus 2 is it's true, right? So we will number modulus 2, that means a number divided by 2, right? So you will get here 6 divided by 2 equals 3, right? So else, so we don't have to bother about this else because it's this is true here, right? So we got 3 as a number, right? So what we can do for the second iteration, we will get 3 here, and 3 not equals 1 is true. So now we will print the number. So here we will print 3, and 3 modulus 2, so here it will get false, right? It will get false. So we can erase this one, and number equals 3 into number. So 3 into 3 plus 1, so this would be 10, guys. right? 10. So for the third iteration, let's see how many iterations it takes, guys, and it will be really fun, right? So third iteration, while 3, so in our case 10, right? So we will print 10 here, and 10 modulus 2 is true, right? So when it's true, okay, so we'll just do this one, number number 10 divided by 2 would be 5 here, guys, right? So this, let's don't bother about this, okay. So I think it will take some time, right? So fourth iteration, here is 5, right? 5. So we are not getting this line, okay? We are not coming in this else statement anyway. So here it will be 5, and in this case this will not be implemented, right? So this will be false. So it's not coming here. We can erase this one, and you can say 3 into 5 plus 1, so 15. It would be 16 here, guys, right? So let's see what happens eventually, right? Fifth. So 16 is not equal to 1, so here it will be 16, and let's say here we will get n equals 16 divided by 2 equals 8, right? So else would be will not be implemented. So now sixth one, right? So if you say sixth iteration, sixth iteration, 8 would be here, guys, okay? 8 modulus 1, yeah, wait, not equals 1, that's true. Here it should be 8, and 8 modulus 2 is true, right? This would be true, and 8 modulus 8 divided by 2 would be 4. Okay, so we don't need to bother about the else statement here. So, and then maybe we are close, right? So in the seventh iteration, it would be 4. Yeah, was it 4? Yes, 4. So 4 not okay. So here 4 modulus 2 becomes 0. So 4 divided by 2 would be 2, guys, right? So and finally in the next iteration we will get 1, right? Eighth iteration, guys. So here it should be 2 not equals 1, that's fine, and 2 here, and 2 modulus 2 becomes 0. So here 2 divided by 2 would be 1. So finally we got 1, guys. Okay, so finally we get we get 1, guys. Okay, so this is what Collat's conjecture mean, guys, right? I hope you enjoyed this video. See you in the next video, and if you like my videos and if you think this is really enriching your programming knowledge, please let me know and support me, guys. I need your support. Thank you.